Hi Year 12, this is our second video for the solutions to the 2021 Extension 1 Maths HSC exam, and in this video we'll look at questions 11 and 12. Question 11a, nice easy one to begin with. Find I plus 6j plus 2i minus 7j, and we can just collect like terms together. So we're going to get 3i, 6j take away 7j is minus 1j. 11b, expand and simplify. So we're using binomial theorem. We are going to get 4c naught, 2a to the power of 4, negative b to the power of naught, plus 4c1, 2a cubed, negative b, plus 4c2, 2a squared, negative b squared, plus 4c3, 2a, negative b cubed, plus 4c4, 2a to the power of naught, negative b to the power of 4. Now I've put a couple of extra terms in. You probably wouldn't put these in if you were doing it, but never mind. Equals, we have got 2 to the power of 4 is 16a to the 4, plus 4 times 8a cubed times negative b, plus 6 times 4a squared times b squared, plus 4 times 2a times negative b cubed, plus 1 times b to the power of 4 equals 16a to the power of 4 minus 4 8s are 32, a cubed b, plus 24a squared b squared minus 8ab cubed plus b to the power of 4. C. Use the substitution u is equal to x plus 1 to find the integral. So u equals x plus 1 du is equal to dx. So substituting in. I need to substitute for x. So just making x the subject. X is equal to u minus 1. U minus 1 square root of u du. Expanding and putting it into index form, u times u to the half is u to the 3 halves minus u to the half du. And now integrate u to the 5 over 2 divided by 5 over 2 minus u to the 3 halves over 3 halves plus c is equal to 2/5. I'm going to substitute back for u, x plus 1 to the 5 over 2 minus 2/3 x plus 1 to the 3 halves plus c. 11d, a committee containing 5 men and 3 women is to be formed from a group of 10 men and 8 women. In how many different ways can the committee be formed? So from the 10 men, we want to choose 5, and from the 8 women, we want to choose 3. And putting that into the calculator, 10c5 times 8c3 equals 14,112. E. A spherical bubble is moving up through a liquid. As it rises, the bubble gets bigger and its radius increases at the rate of 0.2 millimeters per second. At what rate is the volume increasing when the radius reaches 0.6? Express your answer in millimeters cubed per second rounded to 1 decimal place. So we want to make dv dt. So we know the volume of a sphere is 4/3 pi r cubed, and dv dr would be equal to 4/3 times 3 pi r squared, which is 4 pi r squared. So dv dt is equal to dr dt times dv dr. It's equal to 0.2 times 4 pi r squared, and at r is equal to 0.6, dv dt equals 0.2 times 4 pi 0.6 squared, which is 0.2 times 4 times pi times 0.6 squared to one decimal place is 0.9. 0.9 millimeters cubed per second. Question 11F. Evaluate the integral between 0 and root 3 of 1 over the square root of 4 minus x squared dx. So it is inverse sine. We do need our formula. A is going to equal 2. So it equals inverse sine of x over 2 in between 0 and root 3, which is inverse sine of root 3 on 2. Take away inverse sine of 0. Inverse sine of root 3, that's 60 degrees, which is pi on 3. And inverse sine of 0 is 0. And 11G. By factorising or otherwise, solve 2 sine cubed x plus 2 sine squared x minus sine x minus 1. Now, often when you've got these four terms, a really nice way to factorise is just to factorise the first two and then the next two. So let's see whether that will work. 2 sine squared x outside of sine x plus 1, take away sine x plus 1 equals 0. And bringing that factor out the front, sine x plus 1, that's a 1 there, and 2 sine squared x minus 1 is equal to 0. So either sine x will equal negative 1, or solving this, and we can do this separately if you want to, or you might be able to see it just by looking at it. It's going to be plus or minus 1 over the square root of 2. We want it between 0 and 2 pi. So the first one there is a boundary value. Sine curve looks like this. That's going to be 3 pi on 2. And then we want plus or minus 1 on root 2, which means going around all four quadrants. Inverse sine of 1 on root 2 is pi on 4. We're going to get 3 pi on 4, 5 pi on 4, and 7 pi on 4. 11H. The roots of x to the power 4 minus 3x plus 6 are alpha, beta, gamma, delta. What is the value of this? Alright, so let's make a common denominator. Alpha, beta, gamma, delta. We are going to get a mess on top. Beta, gamma, delta. Oops, that's a delta there. Plus alpha, gamma, delta, plus alpha, beta, gamma. So we want the product of the roots, and we want the triples, the sum of the triples. So remember, we're going to have the sum of the roots, then the sum of the pairs, then the triples, and the product. So this one is minus b on a, c on a, minus d on a, e on a. This is A, B and C are 0, D is 3, and E is 6, D is negative 3. So some of the triples is going to be negative D on A, which is 3 on 1. And the product of the roots is E on A, E is 6. So therefore, it is going to be equal to the triples on top, 3 over 6, which is a half. 12a. The direction field for a differential equation is given. The graph of a particular solution to the differential equation passes through the point P. Sketch the graph of the particular solution that passes through the point P. Now there are multiple solutions. What you've got to try and do is stay parallel to these little tangent lines. But beyond that, there's no real rules. So just sort of like this, and then I'm going to come up. You try not to cross any of them, but anyway, there's one example. 12b. A bottle of water with temperature 5 degrees is placed on a table in a room. The temperature of the room remains constant, 25 degrees Celsius. After t minutes, the temperature of the water in degrees Celsius is capital T. The temperature of the water can be modelled using the differential equation here. K is the growth constant. After 8 minutes, the temperature of the water is 10 degrees Celsius. By solving the differential equation, give the value of T when the temperature of the water reaches 20 degrees and give your answer to the nearest minute. Alright, so we need to solve this. So I'm going to turn it upside down, put little t on top. It's equal to 1 on K brackets t take 25. So little t is equal to 1 on k, integral d capital T on capital T take 25, which of course is 1 on k ln t minus 25 plus c. Now we're going to run into strife if we substitute in 5 degrees when t is 0, because we'll end up with a negative here. So I'm going to turn this around first. We're going to get t take away c is equal to 1 on k ln t take 25. So k t minus c is equal to ln t take 25, and e to the k t minus c is equal to t minus 25, so t is equal to 25 plus e to the kt times e to the negative kc, and I'm going to make that into its own constant. So this is equal to 25 plus a e to the kt. Now let's resolve these constants. So when t is equal to 0, capital T is equal to 5. So 5 is equal to 25 plus a e to the 0, e to the 0 is 1. And so a is equal to negative 20. T is equal to 25, take 20, e to the kt. After 8 minutes, the temperature is 10 degrees. So 10 is equal to 25, take 20, e to the 8k. 20 e to the 8k is equal to 15. E to the 8k is equal to 15 on 20 is 3/4. 8k is equal to ln of 3/4. K is equal to ln 3/4 divided by 8, which is ln 0.75 divided by 8, which is negative, put down here, negative 0.03596. So now let's answer the question. Find the value of T when the temperature reaches 20 degrees. So 20 is equal to 25. Take 20, e to the negative 0.03596 t. 20 e to the negative 0.03596 t is equal to 25, take away 20, which is 5. E, negative 0.03596 t is equal to 5 divided 20, which is 1/4. Negative 0.03596 t is equal to ln 0.25. T is equal to ln 0.25 divided by negative 0.03596 equals ln 0.25 on negative 0.03596 equals 38.55. What is this in minutes? Give your answer to the nearest minute. So 38.55, nearest minute is 39 minutes. Sketch the graph of t as a function of little t. Let's remind ourselves of what exponential curves look like. Here is e to the x. If we want e to the negative x, we are reflecting in the y-axis. And if we want negative e to the negative x, we're going to take this guy and reflect in the x-axis, like this. We also want to move it up 25. So let's take our y-axis, which is going to be capital T, and we'll split it into 5, so 5, 10, 15, 20, 25. Has an initial temperature of 5, and we know that this is going to be an asymptote here at 25. So it's going to look like this. 12c. Use mathematical induction to prove this. For all integers, n is greater than or equal to 1. So we'll start by proving n is equal to 1. So our left-hand side is equal to, I'm going to put it into here, 1 over 1 times 2 times 3, which is 1/6. And right-hand side is equal to 1/4. Take away 1 over 2 times 3, which is 1/4, take away 1/12. A quarter take away a 12th is a 6th. Therefore, true for n is equal to 1. Now let's assume that it is true for n is equal to k. So in other words, the sum of 1 over, let's use r plus 1, r plus 2, from r is equal to 1 up to k, is equal to a quarter. Take away 1 over 2, k plus 1, k plus 2. Now let's prove it's true for n is equal to k plus 1. So we are required to prove that the sum r equals 1 up to k plus 1 of 1 over r plus 1, r plus 2 is equal to a quarter. Take away 1 over 2, k plus 2, k plus 3. Okay, so let's set up our proof. We want the sum to k plus 1 will equal sum of k terms plus our k plus 1th term. So our sum to k terms, just from here, is a quarter minus 1 on 2, k plus 1, k plus 2, plus our k plus 1th term, which is this guy here, but with a k plus 1 in it, k plus 1, k plus 2, k plus 3. Alright, now let's have a look at where we want to get to. So we want a k plus 2 and a k plus 3 in the denominator, and the quarter can stay by itself. So let's try and join this together with a common denominator. I'm going to have to watch these negatives here. It's a minus. Alright, let's just do a common denominator. We're going to get 2, k plus 1, k plus 2, k plus 3. Okay, so this guy here, he needs a k plus 3. This is going to be a minus here, okay, because I'm kind of factorizing the negative out. And this one just needs a 2. I think we're there. Just about. Equals, I'll go down here, equals a quarter minus k plus 3 minus 2 is k plus 1. Running out of room. 2, k plus 1, k plus 2, k plus 3, cancels, equals 1/4 minus 1 over 2, k plus 2, k plus 3. Therefore, true for n equals k plus 1. Therefore, by the process of mathematical induction, true for all n. 12d, a function is defined by f of x is equal to 4 take away, and in brackets 1 minus x on 2 all squared, for x in the domain negative infinity up to and including 2. Sketch the graph of y equals f of x showing the x and y intercepts. Alright, so let's start with the intercepts. When x is equal to 0, y is going to equal 4 take away 1 squared, which is 3. So there's the y-intercept. And when y is equal to 0, one minus x on 2 all squared is equal to 4. 1 minus x on 2 is equal to plus or minus 2. X on 2 is equal to 1. Let me think about this. I'm taking that over there, this over there, plus or minus 2, which is equal to 3 or negative 1. And so x is equal to 6 or negative 2. But our domain doesn't go as far as 6. So we're only going to have 1 here, negative 2, 0. Now we know that this is going to be some sort of concave down parabola, so we need the turning point. Now it is in vertex form, so the vertex is going to be what makes 0 here, which is 1 take away x on 2 is equal to 0, x on 2 is equal to 1, x is equal to 2. And then just substituting back into the formula, we get f of 2 is equal to 4 take away 0, which of course is 4. So our turning point or our vertex is going to be the point 2, 4. All right, we're ready to sketch this. So we want 0, 1, 2, 3, all the way up to 4. And we want -2. We have got the x-intercept there, y-intercept here, and up to here. We have the turning point there. So it's going to look something like this. Actually came out better than I expected. Part 2, find the equation of the inverse function and state its domain. Okay, so from the previous graph, we could see that the range was everything up to and including 4. So from -infinity up to 4. So for the inverse function, that's going to be the domain. Right, now let's do this. X is equal to 4, take away 1 minus y on 2 all squared. 1 minus y on 2 all squared is equal to 4, take away x. 1 minus y on 2 is equal to plus or minus the square root of 4 minus x. And so y on 2 will equal 1 plus or minus the square root of 4 minus x. Y is equal to 2, 1 plus or minus the square root of 4 minus x. Now we need to figure out whether it's going to be plus or minus in here, but because we're up to and including 4, we've got the negative numbers, we're going to want the negative. So f inverse x will be 2, 1 minus the square root of 4 minus x. And finally, sketch the graph of the inverse function. So I've got these 3 points here. We are going to switch the coordinates around. So -2, 0 becomes 0, -2. And this one is 3, 0, and our turning point will be at 4, 2. So let's plot those points. So I need to come out here, 4, 2, and we have got 3, 0, and we have 0, -2. I'm just making sure that that makes sense because it should reflect over the line y equals x. So let's draw this in. Where's a good colour? Let's do blue. And so this is the graph of the inverse, and this one up here is the graph of the function.